Hi, I am Alper Yazar. Welcome to the second part of the video series about my ISO ESPRS 422 project. This video is for anyone interested in board schematic or layout or anything else, and makers who want to make his or her own USPRS 422 board copy. In this video, I will talk about design files published on GitHub. Enjoy the video. What you see is a virtual computer. I'm going to use this virtual computer for the next couple of videos. It's running Windows XP Service Pack 3 and it's a fresh system. An ISO ESPRS 422 board was never plugged to this virtual machine and no driver related to the board was installed. In the next videos, we will see the driver installation together. I installed only programs that are necessary to view the project files. We will use them in a minute. Whether you are a maker or a curious person, first you should obtain the project files. Let's open our favorite browser to access them. You may click to the link shown in screen or visit my webpage, which is www.alperyazar.com. Okay, click to Projects. Click to Continue under ISO ESPRS 422 section. Then click to Link for Files. You will be redirected to the GitHub repository. If you are familiar with Git, you may choose to clone the repository directly. If you have no idea about Git or don't want to use it, you can download all files as a single zip file. Let's get the zip file. Okay, save it to the desktop, for example. On GitHub page, you will find some explanations about folder structure and files. These README files are also included in our zip file, so you don't have to follow the GitHub page for README files. Now, let's decompress our zip file. Okay. I want to remove the master word from the folder name. Now let's open the folder. As you can see, the folder structure is same as the structure shown in the GitHub page. You may delete the .git files if you are not planning to play with Git. These files. Also, in some folders, there are README files with .md extension, but these are ordinary text files and can be opened by any text editor. For example, I use Notepad++. This is the source code of the text shown in the GitHub page. I recommend you to skim these README files. Okay. Now, let's take a look at the folder structure. There are 8 folders. And let's begin with the schematic folder. The schematic is given as a PDF file. In this virtual machine, its icon is the Fox icon of Firefox. I don't know why it is, but this is a PDF file actually. Schematic is a single A4 page, and you can study the schematic by using this file. Let's look at the PCB folder. Also, there is a small README file in this folder. You can read it either using a text editor or from the GitHub page by clicking the PCB. Okay, let me continue with my text editor, Notepad++. So, the first file in this folder is a computer-generated photo of the component site. And the second one shows the solder site, like that. There is a PDF file in this folder. You can see layers of the PCB one by one. For example, this, I think, solder mask layer. This is KiCad generated file, and one thing I don't like about KiCad is that it doesn't say which page is which layer. You have to guess by looking it. I haven't tried the new version of the KiCad. Maybe it's fixed in the new version. Nevertheless, you don't need this file so much. It's an extra file. There is a free 3D PCB viewer called Zavs PCB. Please correct me if the correct pronunciation is different. Actually, I wrote a short review about it on my blog. Link is given in the README file in the root folder. This software generates 3D view of PCB from Gerber files. This is my review about the software on my blog page. Click Zavs PCB. I generated my file using version 0.0002 as given in the README file, and this is the latest version at this moment. Once you install it, you can open this file. This is generated by using Gerber files found in the Gerber folder. For example, you can rotate the PCB. You can show or hide each layer. Like that, one by one. You can also highlight a net by pressing the N key, like that. Actually, it works better. I think since it is a virtual machine, its graphic card isn't so good. Okay, Zavs PCB is very good actually. I tried it for larger boards having more than 2 layers, and it works perfectly. Although I haven't tried it yet, you can view also components if proper files are supplied to Zavs PCB. Not only limited to bare PCB. You can peel the board layer by layer, like that. I suggest you give a try to Zavs PCB. It's a handy tool, I think. Okay, if you want to make your own board, first you must have the PCB. If you are planning, please contact me so I may send you a PCB free of charge if it is possible. Also, I may able to send some components too. Anyway, for PCB production, you will use Gerber files. Let's look at the corresponding README file in this folder. Each file is explained here. The .txt file is the real file, and there are 6 screen, solder mask, and copper layers for both component and solder side. These are sufficient for PCB production. Okay, let's look at one of these files using Gerber Weaver of KiCad. Okay, let's choose let's choose the bottom copper layer, for example. It's the bottom layer of the board. Okay. After obtaining a PCB, you need necessary components. List of components are given in the BOM folder. There is a PDF file here. Components are listed with their schematic and layout references. Also, you should read the description column. I highly recommend. And there is a link at the top. If you click, you will be redirected to Octopart. From Octopart, you can view the list online. You can find up-to-date cost of a single board. For example, the most expensive component is converter of analog devices. Also, you can see prices from different distributors. From here. The same list given as an Excel file. The .txt file is exported from KiCad. Maybe it become useful during placing and soldering. The remaining folders aren't necessary at this moment. Later I will talk about them in detail, but let me briefly explain them. Driver folder includes necessary USB drivers for different operating systems. And necessary firmware settings for different operation modes are given in firmware folder. A nice USB RS422 board should be programmed using the correct setting prior to operation. And lastly, some tools are given in the utility folder for testing and programming. For board production, the only necessary folders are Gerber and BAM. Also, you can view the schematic if you want. Finally, let's look at the KiCad folder and check the files. Let's open the KiCad project. By the way, my KiCad version is the latest stable version published in 2013. However, if you check the official KiCad website, they recommend a release candidate version for new designs, not this one. And I didn't check this project with the new KiCad. Now let's check schematic. You can view or modify it. Looks good. Now let's check layout. Similarly, you can also modify it. And all layers. All layers look okay. Good. No problem. Okay, these are the files of the ISO ESP 422 project. In the next video, I will talk about my recommendations about soldering and testing. See you.